Hello, welcome to my channel. In today's class, we'll be resolving this partial fraction. They say we should resolve this into partial fraction. And last class, we discussed a bit about partial fraction, where we discussed the axioms or the rules involving resolution into partial fraction. And the first rule says, if the numerator, the power of the numerator must be of lesser power than the denominator. So the power of the numerator must be less than the denominator. If it is not less than the denominator, then we must divide using the long division. And we'll see how to resolve using long division in polynomial. So now, we'll be resolving this now. If you look at this, the power are equal. So there is no difference. So the numerator is not greater than the denominator. Had it been is greater than the denominator, then we are going to divide using the long division. So now since they are equal, then and if we open this bracket, we see that the denominator is even more than the numerator. So we can resolve this now into partial fraction. So this can be resolved into partial fraction by saying the denominator here, we have a quadratic equation. So since it is of quadratic equation, then we follow using the fourth axiom on partial fraction. So now by fourth axiom, it says this is ax plus b divided by the first value here, which is x squared plus 1, then plus the second value is cx plus d divided by this second quadratic equation, 2x squared plus 3x plus 1. So now we are resolving these two into partial fraction. So now this is how we resolve. Then we simplify further, and by simplification we are going to multiply each term by the LCM, and the LCM is the product of this and this, which is this value. So now if you multiply each term by the LCM, this and this, we'll notice that this will vanish, leaving the numerator here, which is 3x squared plus 2x minus 1 equal to, multiply this term by the LCM, the whole of this value. This will cancel this, leaving this times this. So I will have ax plus b times this value, 2x squared plus 3x plus 1. Then next, multiply this fraction by the LCM, which is this and this. So this will cancel this, leaving this times this. So I'll have plus cx plus d times this one now, which is x squared plus 1. So from here, I can open the bracket and then multiply each term. So now, by simplifying, I will have 3x squared plus 2x minus 1 is equal to, open this bracket, ax times 2x squared. I will have 2ax cubed. This is 1x, this is 2x. So if you are multiplying, we add their powers, applying the law of indices. So next we say plus ax times 3x. I will have plus 3ax squared. This is 1x plus 1x making 2x, so I have x squared. Then plus ax times 1, I will have ax. Then plus. Next we multiply this b by these entities. B times 2x squared, we have 2bx squared. B times 3x, we have plus 3bx. B times 1, we have plus b. Then next we multiply these entries also. Cx times x squared, we have plus cx cubed. Then cx times 1 is plus cx. D times x squared, we have plus dx squared, and d times 1, we have plus d. So next we can collect the like terms together. Those with power x, we collect them together. So here we said this is with x cubed, ax cubed. Anything with x cubed, we collect it together. We have plus cx cubed. And that is all. Then we collect those with x squared. We have plus 3ax squared. This is another x squared. We have plus 2bx squared. This is another x squared. We have plus dx squared. Then we collect the ones with x also. We have plus 3bx. I have plus ax plus cx plus b plus d. The one without x values, we also collect them together. So from here we can factorize what is common between each term. So those with x cubed, we can factorize what is common, and the value that is common is x cubed. So we factor it out. Remove x cubed here, I will have 2a, plus remove x cubed here, I will have c. Then plus, what is common between this x squared is x squared. So when I factor out x squared, I will have 3a here left. Plus, remove x squared here, I will be left with 2b. Plus, remove x squared here, I will be having d. Then factor out what is common between this. 3 also, we have x is common. I have 3b plus a plus c. Then the constant term, which is b and d, plus b, d. Then next from here, this is to say 3x squared plus 2x minus 1 is equal to this function. So now if we are comparing the right hand side with the left hand side, we equate the coefficient of x cubed from the right hand side and on the left hand side also. Same thing for x squared. We equate the coefficient of x squared on the right hand side and that on the left hand side. The same thing goes with the constant. So now equating the coefficient of s cubed here, the coefficient of s cubed on the right hand side here is 2a plus c is equal to, what is the coefficient of s cubed here? We don't have s cubed on the left hand side, so we say the coefficient of s cubed here is 0. Let me call this as equation 1. The next, equating the coefficient of x squared. Coefficient of x squared here is 3a plus 2b plus d is equal to, what is the coefficient of x squared on the right hand side is 3, because this is x squared, so the coefficient of x squared here is 3, so this is equal to 3. We say this is equation 2. Next, the coefficient of x there is 3b plus a plus c is equal to, the coefficient of x here is 2 plus 2, which is equal to 2, so this is equation 3. And next, the coefficient of the constant term, which is b plus d. The constant term here is minus 1. So I have this is equal to as minus 1. So let's say this is equation 4. So now these are the 4 equations I have. So now picking any of these equations and then substitute, we are going to use substitution method to solve. This is simultaneous linear equation, right? So we can solve simultaneous linear equation using substitution method. So now let me use substitution method to solve the values of a, b, c, and d. So now from equation 1, let me start from equation 1. Equation 1 says 2a plus c is equal to 0. Let me make c the subject. If c, this implies that c is equal to minus 2a. Let's say this is equation 5. c is equal to minus 2a. I make c the subject. This 2a crosses the equality, it becomes minus. So now also from equation 4, and equation 4 is b plus d is equal to minus 1. Let me make d the subject. D will now be equal to minus 1 minus b, right? If I take b to crosses the equality, so let me say this is equation 6. D is equal to this value. So if I substitute the value of d in equation 2, let's say put 6 in 2. Put equation 6 in equation 2. And equation 2 is this. Equation 2 is 3a plus 3a plus 2b plus d is equal to 3. This is equation 2, right? So now we are putting equation 6 in equation 2, meaning we are substituting the value of d in equation 2. So now we put the value of d in this equation. So from here we said put equation 6 in equation 2, and equation 2 is given by this, and we are substituting the value of d, which is equation 6. So d is minus 1 minus b. So wherever we see d, we substitute it by minus 1 minus b. So now on substitution, we have 3a plus 2b minus 1. Instead of d, we have minus 1 minus b is equal to 3. So now if we simplify further, 3a plus 2b minus b will give us b plus b. Then minus 1 is equal to 3. Let's take this one to crosses the equality. Therefore, 3a plus b is equal to 3 plus 1, which is 4. So 3a plus b is now equal to 4. So let's say this is equation 7. So we'll call this one equation 7. So next, I can also put the value of c, meaning put equation 5 in equation 3. I have c in equation 3. So now let's substitute for c to be minus 2a in equation 2, meaning put equation 5 in equation 3. So now if I substitute for 5, equation 3 is 3b plus a plus c is equal to 2. So the value of c here is minus 2a. So therefore I have 3b plus a minus 2a now. Instead of plus c, we have minus 2a equals to 2. So simplify, a minus 2a is minus a. So I have 3b, a minus 2a is minus b, minus a, sorry. I have 3b minus a is equal to 2. So let's say this is equation 8. So now if you compare these two equations, from equation 7 and 8, from 7 and 8, I will have 3a plus b is equal to 4. This is equation 7, right? And also, this I can write minus a plus 3b. If I rearrange, is equal to 2. This is equation 8. So now by rearranging, I will have this. So now I can simplify these two simultaneous linear equations together by elimination method. So I want to eliminate one of the value. How do I eliminate one of the value? I can eliminate a by multiplying equation 1 by the coefficient of a, which is 1, and multiply equation 8 by the coefficient of a here, which is 3. So if I multiply this equation by 1, this by 3, I will eliminate a. Meaning if I multiply them together, 1 times 3a, I will have 3a, plus 1 times b is b, is equal to 4 times 1 is 4. The next, minus a times 3 is minus 3a, plus 3 times 3 is 9b, is equal to 2 times 3 is 6. So from here, I can add them together. So let me use this side of the board. So here, I have, when I add them together, if you add this together, 3a plus times minus is minus. So 3a minus 3a will give you 0, right? Then b plus 9b, meaning 1b plus 9b will give us 10b. So I have 10b here plus 10b is equal to 4 plus 6 is also 10. So what I have here is 10b is equal to 10. So we are looking for b, we divide both sides by 10 by 10. 10 go with 10. So b is equal to 1. 10 here is 1, 10 here is 1. So b is equal to 1. So if b is 1, I can substitute the value of b in any of these equations, either 7 or 8, to find the value of a. So now let's put b in equation 7. Put the value of b in equation 7. And equation 7 is 3a plus b is equal to 4. So when b is 1, I have 3a plus 1 is equal to 4. So 3a is equal to 4 minus 1. 3a is equal to 3. So divide both sides by 3 by 3. 3 go with 3. So a is equal to 1 also. So when b is 1, a is also 1. So we can substitute the value of a in any of the equation again. Put a in any of the equation. Maybe put a in equation 5 to find the value of c. So when we put a in 5, put a in equation 5 to find c. And equation 5 says c is equal to minus 2a. So when a is 1, c is equal to minus 2 times 1. And c is equal to minus 2. 2 times 1 is 2, so c is equal to minus 2. So if c is minus 2, I can also substitute the value of any of the variable. In equation 6, I can put the value of b to find b. So again, we said put the value of b in equation 6 to find the value of d. And equation 6 says d is equal to minus 1 minus b. So therefore, d is equal to minus 1. The value of b is also 1 minus 1 minus 1. So d is equal to minus 2. So the value of d is minus 2. So therefore, my equation will now be 3x squared plus 2x plus 1 all over x squared plus 1, this is minus 1, then into 2x squared plus 3x plus 1 is now equal to, we said is ax plus b all over x squared plus 1 plus cx plus d all over 2x squared plus 3x plus 1, right? So now we are substituting the value of a, b, and c. So we're substituting the value of a, b, and c in this equation. So how do we substitute? We know that the value of a, we say the value of a is 1. So put a to be 1 here. So this is equal to the expression, this is now equal to the value of a is 1. We have 1x plus b. The value of b is also 1. So I have plus 1 divided by x squared plus 1 plus the value of c. C is what? We say c is minus 2. We have minus 2x plus the value of d is also minus 2. So minus times plus is minus 2. Then divided by this, which is 2x squared plus 3x plus 1. So this implies that 1x is the same thing as x plus this 1 all over x squared plus 1, then plus this value we have plus times minus will give us minus 2x minus 2, then divided by 2x squared plus 3x plus 1 as the resolution of this partial fraction. So now this partial fraction is now equal to this value as the resolution into the partial fraction. So thank you for your time. If you have any question, you can drop it on the comment section. And if you are visiting the channel for the first time, kindly subscribe, like our page, and hit on the notification bell. Thank you.